Okay, alright, so we're going to look at a couple examples dealing with graphs and functions. Um, One thing that you have to be able to do is evaluate a function for different types of inputs. Um, and the important thing to realize is that you just need to look at the original function and it tells you exactly what to do with an input. For this one, it says if I plug in an x, I need to square it and add 7. So whatever you plug in, all you have to do is just square it and add 7. Simple enough. So for a, it asks us to do f of 3a. Well, we're just going to have to square the 3a. Remember, you're squaring the input, not just the a, but the 3a. And then you add 7, and that is going to equal 9a squared plus 7. Now, for b, it asks us to plug in b minus 1. Again, we're going to square the input, which is b minus 1, and add 7. Now, this we have to FOIL, so don't just square the b and square the 1 and just be done. That's silly. Remember, you have to FOIL. It will break up as b squared minus 2b plus 1, and then you have the plus 7 on the end. And you should end up with b squared minus 2b plus 8 as your answer. For C, this one's a little more complicated. We are doing the slope formula, basically, of this. So you get, you know, f of x plus delta x minus f of x over delta x. Okay, so f of x plus delta x, again, we square our input, which is going to be x plus delta x. We then add 7. We then subtract away our original function, which is x squared plus 7. Very important that we put brackets in this because we're subtracting. And then we divide by delta x. We then need to break this apart, so I'm going to need some more room. So this up here, again, we have to FOIL. Don't be lazy. You're going to get x squared plus 2x delta x plus delta x squared plus 7. And we'll kind of break this down. Minus x squared minus 7 over delta x. We should simplify this here. We see that we've got an x squared and a negative x squared, so those cancel. Um, we have a positive 7 and a negative 7, those cancel. And so we are left here with 2x delta x plus delta x squared divided by delta x. We have a delta x in each term, so this cancels, and that cancels. And so we are going to be left with, after all, is going to be 2x plus delta x. So when we're evaluating a function, you need to make sure that you are identifying what the main function is doing. Don't just associate it with what an x does. It's telling you, if I input some unknown, I have to take said unknown, square it, and then add 7 to it. Now, our next example is asking us to find composite functions. So, given we have these two functions, what would their composites be? So, A says, what is f of g of x? So, f of g of x. Well, what we're doing here, again, we're taking g, and we're plugging it into f. So we need the output of g as the input of f. So this is going to equal um, f of cosine of x, which is the same thing as 2 times the cosine of x minus 3. Because f tells us to double whatever we plug in and subtract 3 from it. So we doubled cosine and subtracted 3 from it. B asks us, okay, to do g of f of x. Well, f of x is 2x minus 3, so we get g of 2x minus 3. Well, g tells us whatever we plug in, we take the cosine of that. So this is a pretty simple one. We get the cosine of 2x minus 3. So with composite functions, and we'll see them quite a bit in this course, um, you just need to make sure that you are accounting for the correct output and the correct input, and you're good to go. Our last example that we're going to cover is going to talk about even and odd functions and zeros of functions. So it asks us to determine whether each function is even, odd, or neither. Um, so the key for this is we plug in a negative x into each one, and we see what happens. And we see if we get the same answer or we get the opposite answer. And that's going to tell us whether or not we are even, odd, or neither. So just as a quick refresher, even means that if I f of negative x gives me the same value as my function. Odd means if I plug in f of negative x, I get the opposite of my original function. Um, so for a, we've got f of x equals x cubed minus x. So f of negative x is negative x cubed minus negative x, which is the same as negative x cubed plus x, which these two things are in fact opposites of each other. So, which you can see that this is the same thing as negative x cubed minus x. So, because this is the opposite of this, we say that f of x, maybe I'll do some different color, f of x is odd. And to find zeros for this function, we want to set our equation equal to 0. So we get 0 equals x cubed minus x. In this case, we've got two terms. Each term has an x in it. So we don't want to move anything or divide anything out. We want to factor. So we're going to have 0 equals x times x squared minus 1. At this point, we have factored. We have two things multiplied together. So we can say x equals 0 or x squared minus 1 equals 0, which means that x would equal positive or negative 1. So here are the zeros for that function. Um, our last function, b, is g of x equals 1 plus the cosine of x. Um, if we plug in a negative x in for this, we get 1 plus the cosine of negative x, which the cosine of negative x is interesting. So it's as the cosine of x counts up, and the cosine of negative x counts down, but their distance away from the origin is the same. So this is the same as 1 plus the cosine of x. So this is the same graph. This is the same function as before, which means that g of x is even. And then we are going to find our zeros here. So we get 0 equals 1 plus the cosine of x, which means that the cosine of x has to equal negative 1, which if we think back to trigonometry, when does cosine of x equal negative 1? This would be pi plus 2 pi k. So it happens at our angle pi, and every 2 pi from that, you say where k is an integer. Um, so most of the time they will give you some sort of window. This one they haven't, so we need to answer in this way to cover our bases.